Hi, and welcome to our second lesson on factoring. Now, our first lesson was looking at factoring trinomials when our leading coefficient in front of the x squared was just the number 1. Now we are looking at it when the value in front of the x squared is any value other than 1. So in this case, we're factoring when it's an expression or an equation in the form of ax squared plus bx plus c. So don't get confused by this whole setup over here. This is just one way to look at it, which I'll explain. But the first thing that we want to keep in mind when we're factoring this ax squared plus bx plus c, the number in front of the x squared is also going to have to get factored or broken down. So like last time, how we looked at factors of c, what numbers multiplied to be c, we have to keep in mind what numbers would be multiplying to give us a. So one way we can look at this is an algebraic equation where if we're factoring ax squared plus bx plus c, a is going to give us the letters m and n in this equation, which happen to be the first two things attached to x in your binomials. C gets factored to the letters p and q, which are the last two pieces. So, in more simple terms, we'll look at example A here to try to make sense of this. We have 3b squared minus 5b plus 2. So I need a negative in the middle and a positive for a c. So I know my setup's a minus minus, just like in the last lesson. Now we're using b instead of x. No big deal there, just changing a letter. And my number out in front is 3. So 3 can only be broken to 3 times 1. So it doesn't matter which one I start with, but I would start with writing one of my binomials as 3b minus, and then parentheses around that, and then our other binomial simply as b minus a blank with parentheses around that. And now we need to figure out what number goes here and what number goes here. So that would be my first step. So then looking at trying to figure out what numbers go there, we need something that multiplies to be 2. Well, our only options are 1 times 2. But 1 and 2 don't add to be negative 5. What we have to keep in mind now is we're dealing with a 3 as a multiple as well. So eventually we need to test with FOIL to see which setup would work. I know I'm going to be using a 1 and 2, so I just tried 3b minus 1 and b minus 2. So I put the 1 with the 3b and the 2 with just the b. If I FOIL that, I get 3b squared minus 6b minus 1b plus 2. That ends up being 3b squared minus 7b plus 2. That's not what we wanted, so I'm going to try the other combo. 3b minus 2 times b minus 1. When we FOIL that, we get 3b squared minus 5b plus 2. That's the combo we want, so our final answer is 3b minus 2 times b minus 1. So if I'm looking at b, I have 2x squared plus 17x plus 21. So I need to split my 2, and the only option would be a 2x and an x. Then I need to think about numbers that multiply to be 21. Well, that's 7 and 3. Now I'm not sure which order they need to be, but I know they need to add to be 17x in the middle. So I'm going to test it with the 3 with the 2x and the 7 with the x. So 2x plus 3 times x plus 7. When we FOIL that, it gives us 2x squared plus 3x plus 14x plus 21. Combine the like terms, that's 2x squared plus 17x plus 21. So that one works. So this right here is our answer. I don't need to worry about trying the other combination. Then in C, now my number out in front is a 4x for 4x squared. So 4 can be split to 2 times 2 or 4 times 1. So I know my setup's going to be this or this. Then I need numbers that multiply to be 30. So in this case, I have 1 times 30, 2 times 15, 3 times 10, or 5 times 6. And then I need those to eventually add to be 43. So my first thought is, if I'm getting a 43 in there, I'm going to need to make a number quite a bit bigger unless it's something like the 30. But I'm just going to try a combination. So in this case, it's kind of a guess and check approach, but I use the 4x plus blank and the x plus blank setup, and I got lucky. I put in a 3 and a 10, so 4x plus 3 times x plus 10. When we FOIL that, 4x times 4x is 4x squared. On the outer, 4x times 10 is 40x. Inner, 3x, which gives us 43x. And then last, 3 times 10 is 30. So in this case, 4x squared plus 43x plus 30 is what we want. So that right there is our answer. So then we'll look at D, E, and F here. So in D, E, and F, if I'm breaking an 8, I know it can be a 4 and a 2, or an 8 and a 1. So I just tried 4k plus and 2k plus. Then 15 can be 3 and 5, or 1 and 15. So I use the 5 and the 3. Plug them in one setup. Foiled it. And it ended up working. So my answer is 4k plus 5 times 2k plus 3. And then I'm going to leave E and F for you to look at on your own if you want, because I want to move down to what happens if these ones up here were all C at the end being positive. Now again, what if C is a negative? If C is a negative, just like last lesson, that tells me my combination is a plus minus for the binomials. So I'll have a plus and a minus. The rest of the setup and approach stays the same as the previous examples. So if I have a 7x squared, I need to split the 7, 7 and 1. Factors of 28 are 4 and 7. And then I just tried a combination and foiled it to check. So 7x squared plus 4, x minus 7. When I FOIL that, I get 7x squared plus 4x minus 28x minus 28. So if I look at that, oh, sorry, that should not say 28x right there. Correction. That should be, because if I'm foiling 7x times x, 7x squared, then on the inside, 4x outer, 7x minus, that would be a negative 49x. So that's what that should be, minus 28. And then when we combine in the middle, a negative 49 and a positive 4 gives me a minus 45x, which is what we want in the middle, our minus 28, and then the 7x squared to start. So that would be our answer. Get rid of that. Now, in B, we have 10 to start, so that could be split to 10 and 1 or 5 and 2. You just have to try a combination. At the end, we have 9, so that could be 3 and 3 or 1 and 1. So again, you write out the different combinations and try them. We know the plus minus. So in this case, I have 10m minus 1, and then an m plus 9. 10m times 9 would be 90m, right there, minus 1m in the middle, gives me my positive 89m. So that's the setup I want. So that would be our factored form. So then C is a similar setup. At the end, we have a 60. So I could have 6 times 10. I could have 3 times 20. There's a few different options in there. 15 times 4. And then with the 7, though, we only have a 7. So 7x and x. We know it's a plus minus because that's a negative. And I just tried the 10 and 6. In this case, 7x times x is 7x squared. Outer, 7x times negative 6 is negative 42. Inner, positive 10x. So that gives me a minus 32x minus 60. So D, E, and F are all similar type problems. In D, it ends up being factorable. E, I'm not going to worry about because that's a regular school year type problem. So for summer school, we're not going to worry about E here. Get rid of that one. And in F, problems like this with the distributive property, we will cover later. So you also don't need to worry about that for now. So don't worry about those ones for this purpose of today's lesson. We'll actually be covering those as this week progresses. Now to solve these, it's the same rules as our last lesson. We want to write this in standard form, so make sure it equals 0. Then we factor the left-hand side, set each part equal to 0, and solve for x. So in this case, 8x squared minus 21x plus 10, already standard form, equals 0. So I'm going to factor the left. The left factors to 8x minus 5 and x minus 2. So in order to solve that, I would split these. 8x minus 5 equals 0, x minus 2 equals 0. So to solve the one on the left, add 5, divide by 8, and x equals 5/8. To solve the one on the right, add 2, and x would equal 2. So we will use that same approach on B. Make sure we write it in standard form first, so get the 12 over to the left by subtracting 12. Factor the left. Split both parts apart, and then solve them for y. So subtract 4 and divide by 7, or add 3 and divide by 4. So y is a negative 4/7 and a 3/4. And then in C, already in standard form, so we have to factor the left, 3x minus 2, 2x minus 3, set each one equal to 0, solve for x, so add 2 and divide by 3, or add 3 and divide by 2, and we get 2/3 or 3/2. And then just like the last lesson, 2 more examples if you want to give them a try. And the word problem at the bottom is an extension enrichment problem, so I'm not going to worry about that for summer purposes. If you want to give it a look and give it a try, you are more than welcome to, but you do not need to worry about that height equation for initial speed and velocity at this point. Now, with this is, as I told you guys last week, probably the trickiest concept that we have to cover this summer. There are many different approaches to factoring quadratics like this. My approach is just one. I will post 3 additional videos that cover other pretty typical approaches. I encourage you to take the time, make sure you practice with this. This skill is crucial for Algebra 2. Probably, like I said, the hardest thing we need to cover this summer. So take your time, watch those other videos, find an approach and explanation that works best for you, and then make sure you practice with that so then you are good to go for our upcoming assessments.